So we're going to put a 1 there, alright, and that's going to make things a bit easier. So our 1 is going to give us one part, and our ln of x squared is going to give us another part. This is going to be pretty easy. So which one should I take the derivative off of? Which one of these is easier to take the antiderivative? Right. So this 1 is easier to take the antiderivative of. Okay. So remember, like I said, you're going to take the antiderivative of 1, and then you're going to, take the whole thing outside the derivative. So the antiderivative of, well, you're going to take the whole thing outside of the integral. I'm sorry. So the antiderivative of 1 is x times log of x squared. Okay. Then you're going to subtract, and then you put your integral. Alright. Now you move it to the other side. I cannot reiterate. So you take the antiderivative of one piece, then you write it out without the integral. Then you move that derivative over to the other piece, and then you include the integral. Okay. So again, the antiderivative of 1 is x. Okay. When you apply the derivative here, using the chain rule, this 2 is going to come out. So you're going to have a 2 times log of x. Okay. And still, let's put that in parentheses to make it easier to see. And again, you're going to have to take the chain rule of what's on the, we're using the chain rule. You take the derivative of what's on the inside and move it out. So that gives you 1 over x. Because the derivative of log of x is 1 over x dx. Okay. So now you have a cancellation. And when you move things down, you get x times log of x squared minus 2 times log of x dx. Okay. Now, we're still not done because we haven't taken the integral of 2 ln of x. So, do you have any ideas on how we're going to do that? I give you a clue. We've done it before. That's right. I knew you could get it. So, we're going to leave this alone. This really becomes, just a pain to bookkeep. But bookkeeping is a lot easier than calculus, right? So, we're going to subtract, okay? And we're going to use curly braces because we're doing yet another integration by parts. So, remember what I told you about integration by parts. You're moving derivatives from one term to the other. Okay. So first of all, without the integral, we're going to take the antiderivative of 2, and that's going to be 2x. Alright. And then we write ln of x. Alright. Then we're going to subtract. Then we're going to keep the integral sign, and we're going to move the derivative over to the ln of x. So you're going to get a 2x times the derivative of ln of x is 1 over x dx. Okay. Alright, so we're going to move everything down a line. X ln of x squared minus 2x ln of x minus, okay, what do we have here? Well, this x and this x cancel out, and you get the integral of 2 dx. Alright? Okay, so the integral of 2 is simply 2x. Alright, and finally simplifying, you're going to get x ln of x squared minus 2x ln of x. Now this is minus and this is a minus, so you're going to get a plus 2x. Oops. Here we go. Alright, now we're going to check our answer. So to check our answer, we just take the derivative of this whole thing, and that should give us our integrand back. So let's move this to the top. Before we erase everything, let's move this up to the top. So you have x ln of x squared. I don't even think you can see that. X ln of x squared minus 2x ln of x plus 2x. Okay, so another subtlety that you might not have picked up on yet, it took me several years to figure this out, but integration by parts is essentially the reverse of the product rule. So if you don't believe me, write out the general formula, you know, the integral of fg dx. Write that out, use integration by parts, and play around with the terms you get and see if you can't get the product rule back. Maybe I'll do that in another video, but it's a Friday night. Yes, it's Friday night. I'm bored. I have no life. So let's go on ahead and check this answer. All right. So we want to take the derivative of this entire thing and see if we get the integrand back. Using the product rule, first you take. We're going to deal with this term first. And first you take the derivative of x, which is 1, times ln of x squared, plus, then you leave x alone, and you take the derivative of this, which is, again, using the chain rule, 2 ln of x times 1 over x. Okay? These terms cancel. So moving over here, you do a minus, and let's put this in square brackets just so we can just to make things easier. So the derivative of 2x is 2 times ln of x plus, and these two are all in the same expression, these two lines. So plus 2x times the derivative of ln of x, which is simply 1 over x. So those x's cancel, and everything is in brackets. Alright, plus the derivative of 2x is just 2. So let's write everything out. You get log of x squared plus 2 log of x minus 2 log of x, and things are looking good, and you get a minus 2 plus 2. What that? And you get ln of x squared. I was lucky. Usually when I do that on the fly, there's a mistake